Welcome to day 51 of our low-level design course. In today's session, we will focus on one of the most critical aspects of system design, building the core modules. Core modules are the heart of your system, and understanding how to translate design into code is a fundamental skill for any software engineer. By the end of this session, you will be able to break down your designs into working code with a focus on ensuring that the code is modular, maintainable, and clear. Our primary objective today is to start implementing the core modules of your system. Once we have our design diagrams and interfaces in place, it's time to bring them to life through code. The core modules represent the key functionality of your system, whether it's order management in a food delivery app or vehicle tracking in a parking system. Today, you will learn how to approach these implementations with a focus on correctness, modularity, and clarity. We will break this process into manageable steps to ensure a smooth development workflow. Before diving into implementation, let's clarify what we mean by core modules. Core modules are the fundamental components that define the essential functionality of your system. Think of them as the building blocks of your application. For example, in a food delivery system, the core modules would include things like order management, restaurant management, and delivery assignment. In a parking lot system, you might have modules for parking slot management, vehicle management, and payment handling. Identifying and understanding these core modules is crucial because they will serve as a foundation for your entire system. As you begin implementation, prioritizing these key modules will help ensure that the system is built incrementally and that each piece works as expected before moving on to others. Let's break down today's activities step by step. First, we will start with module prioritization, which will take about 1 to 1.5 hours. This is an important first step in your implementation process. Begin by reviewing your system requirements and class diagrams. Which modules are essential to your systems? Which ones are dependent on others? Prioritize the modules that are critical to the system's functionality and that can be implemented with fewer external dependencies. This will ensure that you are tracking the most important piece first, and it will make your development process more efficient. You should also consider which modules are simple to implement versus those that may involve more complex logic. Start with the simpler ones to build momentum. Once you have prioritized your modules, it's time to focus on skeleton code writing, which will take about 2 to 3 hours. This is where you set up the foundational structure of your code. You will begin by creating the basic class names, attributes, and method signatures for each core module. Think of this as laying the groundwork for your system's architecture. At this stage, avoid diving into implementation details like logic and data handling. Instead, focus on creating clear, well organized skeletons for your classes and interfaces. By defining this in advance, you ensure that the overall structure of your system is robust and maintainable. The key here is to create a clean and modular design, so don't rush. This skeleton will be the blueprint of your code. Next, we will move into incremental development, which will take another 2 to 3 hours. Here, where the fun begins. You will start writing the actual functionality for your modules, focusing first on the happy part, the successful flow of your system. For example, if you are working on an order management module, implement the flow where an order is placed, processed, and delivered successfully. This will allow you to verify that your basic logic is working correctly. Don't worry about handling errors or edge cases just yet. Focus on getting one core module functional, and once that's done, you can move on to the next. This incremental approach will help you catch issues early and build a solid foundation for the rest of the system. After implementing the basic functionality for your modules, it's time for integration checkpoints, which will take about 1 hour. Now that your individual modules are functional, you will want to test how they interact with each other. This is crucial because even though each module may work independently, the true test is how they communicate and share data. For example, when an order is placed, does the restaurant management module properly notify the delivery assignment module? Are there any issues in the flow of information between modules? During this step, you will identify and fix any integration issues, ensuring that the system works as a whole. It's essential to have simple tests or scripts that verify the interactions between modules to avoid unexpected behaviors later on. Throughout today's session, keep these key principles in mind. First, modularity. Each module should be self-contained, independent, and reusable. This will make your system easier to maintain and extend. Second, stick to the solid principles. These principles will help ensure that your code is scalable, flexible, and easy to test. Readability is another important factor. Write code that is easy to understand so that others can collaborate with you or pick up your work later. Finally, test early and often. The earlier you catch bugs or integration issues, the easier they are to fix. Here are some pro tips to make today's work even more efficient. First, consider mocking external systems. If your system depends on APIs, databases, or other services that aren't yet available, you can use mock implementations to simulate their behavior. This lets you test your modules without waiting for external dependencies. Second, always favor interfaces over concrete implementations. This ensures flexibility and makes your code easier to test and extend. Third, use dependency injection to decouple your modules and make them easier to test. And finally, document as you code. Don't just write your code, write clear comments explaining why you have made certain design choices, which will be helpful for you and others in the future. By the end of today, your deliverables should include the initial version of the core modules. These modules should be modular, readable, and compilable. You should also have basic test coverage for at least one module, verifying that the functionality works as expected. Even though you are just starting with the implementation, having this foundational code in place is a major milestone. Remember, this is just the beginning. Once you have the core functionality working, you can continue building and refining the system. Here's your checklist for the day. Prioritize your core modules based on importance and dependencies. Create skeleton code for your major classes and interfaces. Start implementing and testing at least one core module. Don't forget to verify that your modules interact correctly with each other, and most importantly, ensure that your code is loosely coupled to the use of interfaces. As you progress through the day, keep checking off these tasks to stay on track and make sure you are making consistent progress. Thank you for your attention.